Moving on to the coagulation designing process. Coagulation is the basic step in a very first step in water treatment, which ensures that you are adding sufficient chemicals in terms of removing the physical or the suspended particles from the water, and these particles must be removed through the usage of some chemical dosage of some reagent, which is normally alum in most of the cases, and these chemicals are added through a certain process which is called as coagulation. The basic definition of coagulation is it is the rapid mixing of chemical in the water, and then it is suddenly removed or sent to the flocculation tank where the other processes occur, which would be discussed in later stages. And as far as coagulation is concerned, it is normally we do have a concept of repelling of similar charges particles, but the attraction between the opposite charges, and this chemical reaction or the chemistry concept is being utilized in water treatment by adding the different or the opposite charge chemicals in the water to attract the suspended particles which were having different charge on them. For example, if we look at the water, most of the times we have negatively charged particles in the water which are suspended particles, and they come in your testing as the turbid particles, or they increase the turbidity in your water samples. So to remove these negatively charged particles, you must add some positively charged particle or chemicals in the water, so that both of the negatively and positively charged particles are attracted towards each other and make a larger particle as compared to the previous one. And this larger particle, when joined together to make the flock, has more weight as compared to the basic unit of the negatively charged particle, and this agglomerated or integrated particle, which is called as flock, settles down under the force of gravity due to the coagulation and flocculation process. So all together, both these processes are required for the removal of physical or suspended particles, and these particles are like it is very easy to remove these particles in terms of optimizing the coagulation and selecting the best coagulant in the market or in terms of your water quality. Particle diameter with less than 1 micrometer cannot be removed from suspension by ordinary physical separation processes. Very slow settling characteristics of colloids in terms of Brownian motion hinders their settlement under the effect of gravity. It contributes large parts of pollution and specific cause of turbidity, that is higher ratio of surface area to mass. Surface properties or zeta potential and electrical charges become more important than sediment under the gravity. If we look at the table, the chart below shows that the length of time that is required for particles of different sizes to settle through the water. For example, if we have a 10 millimeters diameter gravel particle in our water sample, it would take almost 1 second to settle down for 1 meter. And if we have 1 millimeter of sand particle in same water molecule or same water sample, then it would be taking 10 seconds to move downwards for 1 meter. Similarly, if we have less than micron, that is zero point 0.1 micron, viruses and colloids, these may take 2 years for settling themselves for that same 1 meter distance. Similarly, if we have some viruses or colloids of nanometer category, Those may take 200 years to settle down for 1 meter. And the depth of our settling tanks in water treatment is more than 1 to 2 meters. So it's very clear that we must add something, we must arrange something that can be utilized to remove these particles on very faster pace, and we can save our time, and we can optimize our processes. Otherwise we have to build a lot of larger structure, as the detention time or the retention time of the water for the settlement of these particles is very high, and we have to remove these particles prior to sending to the other unit operations. So it was mandatory that you must have a very huge infrastructure in terms of providing the sufficient detention time for the removal of suspended particles from this water sample or water batch. But that issue can be catered in terms of the addition of chemicals which can fasten your process, which can reduce the timeline in terms of the detention time, and which can remove these particles in a very short time period due to their properties or due to their nature. And that's why we add some particles or some chemicals in the water batch to remove the suspended particles in a faster pace. Properties of colloids include colloidal particles are normally charged with respect to the surrounding medium, like hydrophobic, that is clays and metal oxides, water heating. Colloids possess no affinity for the liquid medium. They are readily susceptible to a coagulation, majority of inorganic colloids. अब colloids जो है normally water loving नहीं है और inorganic हैं, and they tend to repel water molecules from themselves. Hydrophilic or proteins या water loving exhibit a marked affinity for water, absorb water and retards flocculation, and frequently needs special treatment to achieve effective coagulation. Majority of organic colloids, when colloidal particles come into contact, they join to form large particles, flocculates and precipitates. अब जो हाइड्रोफिलिक हैं या वाटर लविंग या प्रोटीन्स हैं, ये वाटर को अपने अंदर मिक्स कर लेते हैं, और जिसकी वजह से इनकी सेटिंग और ज़्यादा मुश्किल हो जाती है, एंड दैट्स व्हाई वी नीड टू ऐड सम कोआगुलेंट इन वाटर सो दैट these proteins can be removed from the water sample. और जब ये प्रोटीन्स ऊपर हाइड्रोफोबिक के साथ मिक्स होती हैं या इनका इंटरेक्शन होता है, तो हाइड्रोफोबिक और ये इनऑर्गेनिक और प्रोटीन विच इज़ द ऑर्गेनिक मॉलिक्यूल, तो ऑर्गेनिक एंड इनऑर्गेनिक मिक्सअप हो के अपना साइज थोड़ा इनका ज़्यादा होता है, एंड दैट्स वाई ड्यू टू दी हायर वॉल्यूम और साइज दे सेटल डाउन इन द सेडिमेंटेशन टैंक. Coagulation is also called as destabilization. What is destabilization? We know that the particles, the colloidal particles which were not being able to settle down in the water were stabilized at their positions, and now we have to make them destabilize. That's why we add chemical which is called as coagulation, and coagulation is also called as destabilization because it is resulting in the destabilization of the suspended particles from their positions. All right. Reduction of surface potential by charge neutralization, an enmeshment of colloids in a precipitate, adsorption and interparticle bridging, charge neutralization, adsorption of a species carrying a charge opposite to that of the colloids, reduction of surface potential and destabilization of colloids, increase in dosage of coagulant with increase in concentration of colloids, Overdose of coagulant causes restabilization, optimum coagulation when zeta potential approaches to 0 millivolt. Bridging mechanism, as we discussed earlier, that the proteins and clays or the other inorganic materials, when come across to each other, they join together and they settle down. The joining or bridging of these proteins and inorganic materials is described over here, that we have some polymer which is also as considered as the additional chemical which is added by the plant operator, and then we have a particle which was not settling down in normal water sample. After the addition of these polymers, both of these join together and the particle destabilizes due to the heavier weight as compared to the previous one. Polymer molecule will become attached to a colloidal particle, Coulombic attraction, if the polymer and particle are of opposite charges. Coagulation itself is the addition and rapid mixing of a coagulant or the chemical to destabilize colloidal particles and organic matter. Colloidal matters are of 0.1 to 100 micrometer size. These might be hydrophilic, that these have the affinity of for water. These might be hydrophobic, water hating bacteria as discussed earlier. Coagulation process, step by step, solids are removed by sedimentation or settling, followed by the filtration. Small particles are not removed efficiently by sedimentation because they settle too slowly. They may also pass through filters. They would be easier to remove if they clump together, coagulated to form larger particles, but they don't because they have a negative charge and repel each other like two north poles of a magnet. In coagulation, we add a chemical such as alum, which produces positive charges to neutralize the negative charges on the particles. Then the particles can strike together, forming larger particles which are more easily removed. The coagulation process involves the addition of the chemical, that is alum, and then a rapid mixing to dissolve the chemical and distribute it evenly throughout the water. This is the simple diagram which exhibits the coagulation tank and flash mixing of alum. Then we have the flocculation, which is the slow mixing, and finally we have filtration, flotation, and decantation, whichever process to be utilized after this flocculation process. This is another diagram which is showing the suspended colloidal particles at initial stages, and after the addition of coagulation, these are joined together by the positive and negative charges attraction, and later on all these coagulate after the addition of coagulation, all these larger particles join together to make flocks, and in later stage these flocks are settled down in the sedimentation tank. So this is the process which occurs in the water treatment process to remove the physical turbidity, physical contamination from the water samples, and this is called as the physical treatment as well, physico-chemical treatment as well. Physico means that we are removing the physical suspended particles from the system, and the chemical means that we are adding some chemicals to make these flocks and then remove from the system. So it's a combination of both physical and chemical process. That's why we call the water treatment at this level as physico-chemical process, and it results as the removal of the physical contamination in the water samples. There might be presence of microorganisms over here, and these microbes will be traveling along the water towards the filtration. If some of the microorganisms are removed in the filtration system, the remaining portion will travel to the disinfection system, and at the disinfection setup you must remove all the community of the microorganisms so that the water is considered as the safer for the drinking water purposes. This is the rapid mixing of the coagulation. This is the rapid mixing of chemical into the coagulation tank through some impeller or propeller. Then there is the sedimentation of the flocks, which are relatively larger particles as compared to the previous particles. This is the sedimentation in which the sediments or the flocks are being settled down. After the basic definition of coagulation, we must know about the basic types of coagulants. There are various types. For example, we have categorized various coagulants in primary coagulants, in secondary coagulants, or coagulant aid. Primary coagulants, chemicals that help in destabilizing the colloidal matter, for example, aluminium sulfate, aluminium chloride, ferrous sulfate, ferric chloride, ferrous sulfate, lime, PaCl, polyaluminium chloride, aluminium chlorohydrate. Then secondary coagulants or the coagulant aids, natural, synthetic. The natural secondary coagulants are starch, polysaccharide, gums, etc. While the synthetic or the coagulants which were manufactured in the laboratory or at industrial level are anionic or cationic or non-ionic. Anionic include polyelectrolyte, positively charged, partially hydrolyzed, and polyacrylamide. Cationic include polyelectrolyte plus positively charged polyamines. Non-ionic include the polyelectrolyte polyacrylamide. These are the basic chemical structures of all these species or the coagulants: non-ionic, anionic, cationic. Their formula, their molecular weight range, their uses, and after using their observation, their regarding their performance or efficiency. You can see all together these coagulants as polyelectrolytes, and later on you can discuss or read all these observations in detail. Then we have common coagulants, which is aluminium sulfate and its reaction with water. Obviously, we are adding these chemicals into the water, so all the chemicals would be reacting with the water and resulting in some different ions, and these ions are resulting in attracting the negatively charged particles towards them and making a larger particle, which is later on converted into the flock, and that flock is settled down in the sedimentation tank. So if we look at the, I would try to, there are things which are piling up. I would like to try to explain this on whiteboard as well, and I would share with you that the how these particles are converting themselves to the potential sites for the negatively charged particles, and then attracting those negatively charged particles towards them for the uh, production or the synthesis of a larger particle. So optimum pH range for the aluminum sulfate is 4.5 to 8, and aluminum sulfate when added to the water produces aluminum hydroxide ions, and these ions later on attract the negatively charged particles towards them to make the larger particles for the settling on later stages. Similarly, we have PaLC, less acidic, active over a wide range of pH. ACH, aluminum chlorohydrate, used in membrane filtration plants. Lime, again used in water treatment facilities. Then comes the ferrous sulfate. Once again, its pH is above 9. If the water is alkaline and you have to add some, you can use ferrous sulfate. If chlorine is available as oxidant, reaction can occur at pH as low as 4. You have a very wide range of pH in terms of the chemical reaction of the coagulant. You have different types of coagulants which can operate at any pH, but you have to maintain the cost aspect as well. Then comes ferric sulfate and ferric chloride. The pH for both of these is 4 to 12. Once again, it's a very wide range of the pH for the operation of coagulation and flocculation. These graphs show the active range of pH for the coagulation reaction. You can see the best portion in 6 to 8 pH as 5.5 to 8 pH, 5.5 to 8 pH. In terms of precipitation, coagulation and flocculation, this is for aluminum hydroxide and this is for iron hydroxide. Its pH is 4.5 to 6 or 7.25, while for aluminum hydroxide we do have a pH of 5.7 to 8. Then comes the mechanism of coagulation in which the coagulation takes place. There are four basic steps in terms of double layer compression, sweep flocculation, adsorption or charge neutralization, interparticle bridging or enmeshment. In double layer compression, we do have different layers around the water, different layers around the suspended particle. For example, this was the original suspended particle which was negatively charged, and then we have some positive attraction from the coagulant, and similarly it has made a large number of molecules attached to each other. And if we look at the description, a negative colloidal particle with its electrostatic field adapted with permission from a theory of coagulation useful for design by CP praising in industrial and engineering chemistry. तो ये आपको उनका पूरा एक जो उसकी इलेक्ट्रोस्टैटिक फील्ड है वो शो कर रहा है, और इसमें भी आप अगर देखें तो इसमें डबल लेयर बन जाती है। एक जो इसके वेरी फर्स्ट लेयर है जो कि इसके साथ एसोसिएटेड है बल्क सोल्यूशन के तौर पे आपके पार्टिकल के साथ, और उसके बाद आपकी दूसरी लेयर आ जाती है। जो दूसरी लेयर है उसमें क्या होता है कि आपकी जो फर्स्ट लेयर है उसके साथ वो डिफ्यूज लेयर के तौर पे अटैच्ड है। ठीक है, ये दूसरी लेयर यहाँ से लेके यहाँ तक है, ये डिफ्यूज लेयर है। इसमें आपके ये वाली लेयर में आपका एक ही टाइप की इलेक्ट्रोस्टैटिक फोर्सेस हैं, तो यहाँ पे आपकी इलेक्ट्रोस्टैटिक फोर्स में थोड़ी सी वैरायटी भी है। This is once again the chemical reactions explanation in terms of the colloids. Then we have the pH range of optimizing the coagulation process for alum. These are different type of reactors which are fabricated and which are designed in terms of having propeller or impeller as well. This is the turbine mixer, this is the pedal mixer, this is the propeller mixer, this is the baffled mixer, and this is inliner mixer, and these are the pneumatic mixer. All these type of chemical reactors and the propellers are for the utilization of different purposes in terms of addition and mixing of chemical effectively in the water, entire water sample. So we try different aspects, and we try different technologies to mix the water. We have to consider the energy parameter as well. We have to consider the effective addition of chemicals in the water, and we have to analyze the effective mixing of the chemicals in the water sample, so that the water may be contaminated, free from the physical turbidity. Then determination of coagulant dosage using a jar test may also take place. You must have conducted the experiment over the jar system or the jar setup. Jar setup is a very best and unique example in terms of finding out various steps of the water treatment facility. For example, starting from the coagulation, flocculation, and sedimentation. There are the basic units or the basic unit operations which can be optimized at this single apparatus. Take down volume of the sample, take known volume of the sample, add known increment of the coagulant, rapid mixing for 3 minutes, slow mixing for 12 minutes. Then dosage calculation. If we have to calculate the dosage, for example, if we are requiring 1500 pounds of dry alum as a requirement for the treatment of 15 million gallon of water, then we may convert the dosage, or we may find out the dosage in terms of the dosage would be the total quantity of alum being utilized divided by the total flow into the number of into the conversion unit from gallons to liters. 1500 pounds per day were being utilized as coagulant in this example, and 15 million gallons per day were being treated, and 8.34 is your conversion unit from gallons to liter. So the total answer comes out to be 12 milligrams per liter. So every liter of water would be requiring 12 milligrams of alum in terms of coagulation. तो आपको उस हिसाब से ये केमिकल को भी मैनेज रखना पड़ता है। ऐसा ना हो कि आपने एक बार इसको परचेज़ किया और उसके बाद आपके ऑपरेशन में ये सारा एंड हो गया और आपको पता भी नहीं चला, और अब आपको जब ज़रूरत पड़ी है तो कोई आपके पास सेटअप नहीं है। तो ऐसा तो है नहीं है कि अगर आपने पानी नहीं दिया तो यहाँ पे, या आप उसको ट्रीट करके कम्युनिटी को प्रोवाइड नहीं करेंगे, और आपको ये था कि हमारे पास नहीं है, डोजेज नहीं पड़ी है, या हम ऑप्टिमाइज नहीं कर सके कि कितनी हमें ख़रीद के रखनी चाहिए थी, तो कम्युनिटी तो वेट नहीं करेगी कि आप उनको ट्रीटेड वाटर प्रोवाइड ना करें। तो इसलिए यू हैव टू मैनेज ऑल दीज थिंग्स, और आपको कैलकुलेट करनी पड़ती है बड़ी इफेक्टिवली, और उसके बाद आप ऑपरेट करते हैं उसको। ये इसी एग्जांपल की एक पिक्टोरियल व्यू है कि अगर आपको इससे समझ नहीं आई तो सिंपल इट्स डिवीजन कि आपके 1500 पाउंड से उनको 15 और 8.3 से आपने डिवाइड कर दिया, एंड द आंसर हैज appeared in milligrams per liter. Another example of same category is in terms of gallons of water by 100 pounds of the lime, and calculate the lime dosage in milligrams per liter. First, we must convert volume from gallons to million gallons, as we witnessed in previous example that we use million gallons in the formula. So 100 divided by 0.8 into 8.34, which is the conversion unit, and the answer comes out to be 13.7 milligrams per liter. Sorry. This is the apparatus in which you can optimize all these coagulation, flocculation, and sedimentation processes at your laboratory scale, and it is very authentic apparatus which helps you a lot in finding out the real-time processes at the water treatment plant by interacting with the original samples from the treatment plant. This is the actual picture of that apparatus. You must have seen this apparatus and you must have used and optimized the coagulation and flocculation. Have you used this or have you conducted this experiment, Anwar?
No, sir.
All right, I would like to share that. I would try to ask the lab staff to record this lecture and that would be shared with you as well, inshallah. So after the conduction of the experiment, you can see that these are the samples with the different dosage levels. For example, if we have calculated in this example, we have calculated that to further and to efficiently treat the water, we must have 13 or 14 milligrams of alum in single liter. And now assume that, and actually this is the volume of 1 liter in beaker, and we have added here we have added, for example, we have added 3 milligrams, 5 milligrams, 8 milligrams, 13 milligrams, 17 milligrams, and 20 milligrams. So all these would be of same category. The samples would be of same contamination, and the dosage have been varied to effectively study or find out at what condition or at what dosage the water is being treated effectively. And after the treatment, we can analyze that the water is treated at this, for example, at this level, the water is more clearer, and this was the initial sample, and this was the after the coagulation and flocculation, and this is the sedimentation, and after sedimentation you have this type of product from a single beaker. From all these beakers you have to study all parameters in terms of this array. This was the basic of beaker वन. बेसिक के बाद कोagulation ऐड किया आपने, कोagulation की तो ये beaker वन का step 2, beaker वन का step 3 after coagulation, and beaker वन का step 4 after sedimentation or removal of the suspended particles from the system. तो ये आपके पास हर बीकर के अगेंस्ट जब इसकी वैल्यू आ जाती है, then you take the volume from this final treated water and you measure or observe that in turbidity meter. When you measure it in turbidity meter, then you come across the readings के सबसे ज़्यादा efficient कौन से वाले jar की treatment थी. For example, we select that this jar has provided best efficiency in terms of its results. तो फिर हम इसके लेबल को देखते हुए इसकी डोजेज के अगेंस्ट जो डोजेज है उसको हम एनालाइज करते हैं और उसको आगे फर्दर स्टडी करते हैं और उसके ऊपर काम करते हैं. That's called as the optimization or selection of dosage in water treatment. इसके ऊपर भी थोड़ा सा मैं आपके साथ शेयर कर लूँगा लिटरेचर इंशाल्लाह. These are the graphs or the patterns which are in terms of positive and negative charges, and then charge neutralization in terms of positive and negative charges. Obviously, जब आपका एक पॉजिटिव और एक नेगेटिवली चार्ज मिलेगा तो उससे पहले वो स्टेबल थे और अब वो डिस्टेबलाइज भी हो गए हैं और न्यूट्रलाइज भी हो गए हैं obviously. Coagulation process equipment. Coagulation is occurring in two stages: destabilization of colloids, particle transportation to promote collision of colloids. Objective is to neutralization, destabilization of colloids. The reagents has to be diffused as rapidly as quickly as possible throughout the volumes of the water. The essential features of the good mixing device are the volume of reagent solution added is very small in comparison with the main flow of the water, adequate turbulence by mixing flow direction, adequate back mixing in the direction of flow, and rapid dispersion of the chemicals. ये उसके बेसिक फीचर्स हैं जब आप किसी भी जगह पे कोagulation को इनकॉर्पोरेट करना चाहते हैं. देन कम्स द स्टैटिक मिक्सर्स। इसमें आप कोई डिवाइस लगाने की बजाय एक पैटर्न यूज करते हैं जिसके अगेंस्ट आपका केमिकल जो है वो उसको रिलीज करते रहते हैं, बट ड्यू टू दी हाई टर्बुलेंस इन द वाटर आपका केमिकल उसमें मिक्स होता रहता है, आपको इम्पेलर और उसमें प्रोपेलर नहीं चाहिए होते हैं। फिगर में भी आप देख सकते हैं। और उसके अलावा लैक ऑफ मूविंग पार्ट्स, easy for operation and maintenance point of view, devices, screen, diaphragm installed inside the pipes which cause enough turbulence to diffuse the coagulant। तो होता ही है कि यहाँ से इनलेट आ रहा है, यहाँ पे कुछ उसको टर्बुलेंस देने के लिए डिवाइस ऐड कर दी, यहाँ पे कोई बैफल ऐड कर दी कि पानी ऊपर से नहीं जा रहा, यहाँ से स्पीड अप होके नीचे से जा रहा है। यहाँ पे आप केमिकल ऐड करते हैं इस पॉइंट पे, और इस पॉइंट से जब स्प्रेड आउट होता है तो केमिकल उसमें इफेक्टिवली मिक्सअप हो जाता है। Hydraulic jump do not provide efficient mixing, but this is how it mixes the coagulant at later stages. Then we have two different arrays over here as well, static mixers के point of view से, कि यहाँ पे आप फोर्स्ड जो प्रेशराइज्ड वाटर है उसको आप मूव करवाते हैं और यहाँ पे केमिकल ऐड करते हैं, तो ये इस तरह से मिक्स हो जाता है। सिमिलरली यू कैन ऐड बैफल्स, जो कि डिफरेंस हिंड्रेंस होती है, डिफरेंट जगहों पे आप इंस्टॉल कर देते हैं और वाटर को मूव करने के लिए इधर उधर टर्बुलेंट होना पड़ता है, और जब वो टर्बुलेंट होता है तो उसमें इफेक्टिवली केमिकल भी मिक्सअप हो जाता है। Coagulant from the plane jet turbulence energy dissipation occurs are large volume with little back mixing। यहाँ पे बैक मिक्सिंग नहीं है, यहाँ पे बैक मिक्सिंग है। Suitably placed baffles can intensify energy dissipation with some back mixing, improving mixing efficiency। Then comes the types of coagulants which are being used in the market as commercial. On commercial scale, aluminum sulfate as commercial grade, as reagent grade। ये यहाँ पे reagent grade means कि आप commercial grade में ख़रीदेंगे तो आपको इस तरह से ख़रीदना पड़ेगा, जो कि आपको बहुत ज़्यादा इन्वेंट्री में रखना पड़ेगा। और कमर्शियल reagent grade means कि लेबॉर्ट्री स्केल पे आपको थोड़ा बहुत अगर चाहिए तो आप पाउडर फॉर्म में भी ले सकते हैं, and you can use that coagulant regarding your coagulation process as well. Here we have the classification of surface water with regard to coagulation। आप देख सकते हैं कि आपको डिफरेंट केस स्टडी दिए गए हैं जिसमें ग्रुप 1, ग्रुप 2, ग्रुप 3 एंड ग्रुप 4 शेयर किए गए हैं। इन ग्रुप्स को बड़ी अच्छी तरह से आपने एनालाइज करना है, बड़ी अच्छी तरह से समझ लेना है, सो दैट यू कैन बी एबल टू कंडक्ट दी कोआगुलेशन प्रोसेस इफेक्टिवली। सबसे पहले लो टर्बिडिटी है, उसके बाद आपके पास हाई टर्बिडिटी है, फिर आपके पास केस आ जाता है कि लो अल्कलिनिटी है और हाई अल्कलिनिटी है। दो पैरामीटर्स हैं आपके पास, टर्बिडिटी, अल्कलिनिटी, दोनों का लो एंड हाई आपने चेक कर लिया। अब इन चारों को आपने चार डिफरेंट केस स्टडी में कन्वर्ट करना है, इनके कॉम्बिनेशन को। All the combinations of these four categories would be discussed in the form of group 1, group 2, group 3 and group 4. Group 1 says that high turbidity with low alkalinity, like it is relating high turbidity of 100 NTU with low alkalinity, less than 50 milligrams per liter as calcium carbonate. All right, so group 1 is in this way. With relatively small dosages of coagulant, water of this type should be easily coagulated by adsorption and charge neutralization, and it may need to add alkalinity if pH drops during the treatment। तो अब ये आपके पास एक प्रोसेस आ गया और इस प्रोसेस के अगेंस्ट इसकी जो इजीनेस है वो बता दी गई है, क्योंकि हाई टर्बिडिटी है और अल्कलिनिटी लो है, तो इसमें आप कोआगुलेशन जो है उसमें एड्सॉर्प्शन एंड चार्ज न्यूट्रलाइजेशन इफेक्टिवली कंडक्ट कर सकते हैं। Then comes the high turbidity with high alkalinity, like you have same turbidity but alkalinity has increased. Now there would be a difference between these two. Alkalinity adsorption and charge neutralization will be less effective mechanism than in waters of low alkalinity, and higher coagulant dosages should be used to ensure the sweep coagulation. अब आपको लोअर डोजेज की जगह पे हायर डोजेज यूज करनी पड़ रही है और आपकी एड्जॉर्प्शन एंड चार्ज न्यूट्रलाइजेशन जो है वो भी कम हो रही है क्योंकि आपकी टर्बिडिटी भी हाई है और भी आई है। तो आपकी केमिकल जो है वो उसकी डोजेज जो है वो रिलेटिवली उसकी डोजेज जो है वो बहुत ज़्यादा यूज होगी। द पीएच विल बी रिलेटिवली अनअफेक्टेड बाय कोआगुलेंट एडिशन एंड ऑब्वियसली जब इतनी ज़्यादा कोआगुलेंट की डोजेज आप ऐड करेंगे और हाई अल्कलिनिटी हाई टर्बिडिटी में ही वो यूटिलाइज हो जाएगी तो पीएच को इतना फर्क नहीं पड़ेगा क्योंकि जो कोआगुलेंट होता है उसकी वजह से पीएच भी थोड़ी बहुत वेरी करती है। Then comes the group 3 low turbidity and high alkalinity. This is the low turbidity and high alkalinity. Then we will be discussing low turbidity with low alkalinity. Low turbidity with high alkalinity says that the small number of colloids make coagulation difficult. Addition of some turbidity may decrease the amount of coagulation needed. The principal coagulation mechanism is sweep flocculation with moderate coagulant dosages. While the last case, the fourth case is low turbidity against low alkalinity. The small number of colloids make coagulation difficult and low alkalinity prevents effective aluminum hydroxide formation. Additional turbidity can be added to convert this water to that of group 1 or additional alkalinity can be added to convert it to group 3. It may be advantageous to add both turbidity and alkalinity. तो अब इसमें क्या होता है कि आपकी पीएच जो है वो वेरी करेगी और उसकी वजह से आपको फिर टर्बिडिटी अल्कलिनिटी खुद से भी ऐड करनी पड़ सकती है टू मेंटेन योर पीएच एंड at the same time to remove the suspended particles from the system out. Then what are the factors which affect the coagulation and flocculation? The most commonly used coagulants are alum, ferric chloride, ferric sulfate, cationic polymers, and coagulant concentration of 1 to 3%. Then comes the pH. Initially, it was the type of the factors affecting the coagulation में जो पहला step था that was the type of the coagulant. Second one was the coagulant concentration which is 1 to 3%. Third one is the pH. एलम के लिए इतनी है, फेरिक के लिए इतनी है, and the fourth one is chemical composition of water. तो वाटर के अंदर कंटामिनेशन किस टाइप की है ये चीज़ भी मैटर करती है इन टर्म्स ऑफ योर determination of the factors which are affecting the coagulation and flocculation. Fifth is the nature of turbidity. Particles of different size are easier to coagulate than uniform size particles. Highly turbid waters may require a lesser amount of coagulant than waters with slight turbid. हाईली टर्बिड में लेसर अमाउंट ऑफ कोगुलेंट चाहिए ये क्या बात हुई और लोअर अमाउंट चाहिए स्लाइट टर्बिड में। कंदील आप बताना चाहेंगी ये
यस सर।
ये क्या लिखा हुआ इन्होंने कि हाई टर्बिड वाटर हो तो आपको कोगुलेशन कम करनी पड़े केमिकल कम डालना पड़ेगा। आपकी आवाज नहीं आ रही। कंदील आप सुन पा रही हैं हमें?
यस सर।
वो आपको नहीं आइडिया?
सर नो आइडिया।
बेटा ये जब इसमें टर्बिडिटी ज़्यादा है और कोआगुलेंट आप ऐड कर रहे हैं तो इसका मतलब ये है कि जो लेसर क्वांटिटी उसने लिखी है, इसका मतलब ये है कि आपकी जो क्वांटिटी जो ऐड हो रही है, जो केमिकल आप ऐड कर रहे हैं अपने वाटर सैंपल में टू रिमूव द टर्बिडिटी, वो इफेक्टिवली यूटिलाइज हो रहा है, क्योंकि उसमें हर पार्टिकल को कोई ना कोई पार्टिकल आगे मिल जाता है। हाई टर्बिड है आपका वाटर, तो उसको कोई ना कोई पार्टिकल मिल जाता है और इफेक्टिवली वो उसको रिमूव कर देता है। जबकि लो टर्बिडिटी में आपके जो सस्पेंडेड पार्टिकल्स हैं वो आपकी जो WHO की गाइडलाइन है उससे तो ज़्यादा हैं, लेकिन वैसे लो टर्बिडिटी है। अब लो टर्बिडिटी में यही मतलब हुआ कि पानी में स्कैटर हुए हुए हैं आपके पार्टिकल्स, और जब स्कैटर हुए हुए हैं तो उनको फाइंड आउट करने के लिए आपको ज़्यादा केमिकल ऐड करना पड़ेगा, ताकि कोई ना कोई तो केमिकल का जो आइन है वो जाके उसको अटैच हो, उसको अट्रैक्ट करे। तो इस वजह से आपको फिर ज़्यादा केमिकल ऐड करना पड़ता है, और उसकी वजह से फिर आपके जो कोआगुलेशन है वो सक्सेसफुली आप इम्प्लीमेंट कर पाते हैं। ठीक है ना? तो it's the availability of turbid particles in water which makes the quantity of your coagulant higher or lower. मेरी बात की समझ आई है आपको?
Yes, sir.
All right. Then comes the temperature. Cold water near 0 degree centigrade is difficult to coagulate. Rapid mixing is also a factor which affects the coagulation or the flocculation. Degree and type of mixing, coagulant and flocculant aid are used to improve settling and strength of flocks and to enhance the turbidity and color removal. Examples of aids: activated silica, oxidants, chlorine, ozone, potassium permanganate to aid in color removal, and polymers. Then we have the designing of coagulation chambers. तो ये हम इंशाल्लाह नेक्स्ट लेक्चर में इसको करेंगे, क्योंकि ये थोड़ा सा इसके ऊपर जो है वो मुझे कुछ ना कुछ आपके साथ लिटरेचर शेयर करना पड़ेगा, तभी आपको समझ आएगी, अदरवाइज anyway. We have discussed the introduction of coagulation today, and we would be discussing the designing of coagulation chamber, and the process which is being carried out in the coagulation chamber would be optimized through the numerical processes or numerical calculations, and it would be discussed in the next lecture inshallah. उससे पहले